Welcome back, you guys. This is day 2 of our online learning. So take a minute, try these 2 warm-up questions on a separate sheet of paper and pause this video. When you've given it a try or you're ready to see the answer, go ahead and unpause. So the first question, find the equation of the quadratic that has a vertex of 1, 4 and goes through the point 5, 10. Think back to the idea of plugging in what you know to the easiest form and solving for the a value. Well, if we're given a vertex, I'm thinking the easiest form is vertex form. So I want to start with y equals, and I don't know a, but if it's a vertex of 1, 4, that means this must be x minus 1 squared, and then plus 4 at the end. Again, sorry about my handwriting. I'm trying to get better with this stylus. The next thing we have is we have a point that we can plug in, this 5, 10, where 5 is my x value and 10 is my y value. So I can actually plug that into my equation and use it to figure out what a is. This was something we did before we left for extended break. So hopefully it rings a little bit of a bell. So we've got 10 equals a times, well, 5 minus 1 is 4. 4 squared is 16. And remember, there was a teacher trick right here where I said rewrite it as 16a before you do anything. Otherwise, you might accidentally make that a 20. We can't add the 4. The 16 is with the a first. So just a little recommendation to rewrite it first. That'd be easier. So subtract 4 on both sides. We get kind of a gross a value. That's okay. They both divide by 2, so 3 over 8. So if my a value is 3 over 8, I need to plug that back into my equation with the x minus 1 squared. And then that would be the equation of that quadratic. So for number 2, it says an object is thrown from a building that is 160 feet high. It reaches its maximum height at 196 feet after 1.5 seconds. Find the equation of the path the object follows. So this is actually very similar to number 1. I like drawing a picture because I get kind of stuck with word problems. So there's a building that's 160 feet high, and it's being thrown from there. So it's starting at that height. My assumption is it's going up and then coming back down until it hits the ground. And it reaches that maximum height of 196 feet after 1.5 seconds. That makes me think of the vertex. So my vertex is 1.5, 196. This right here makes me think of a y-intercept. So this is kind of like 0, 160, because that's where it starts. That's its starting point. So we're going to do pretty much the same thing we did for number 1. I'm going to write it with the vertex first. So it's going to be x minus 1.5 squared plus 196. And then I'm going to take that point 0, 160 and put 0 in place of x, 160 in place of y. So let me switch my colors here. So now I've got 160 equals a times, well, 0 minus 1.5 is negative 1.5. And negative 1.5 squared, I'm just doing that off to the side of my calculator real quick, is 2.25. So now I'm going to subtract 196 from both sides. Again, I'm just using my calculator off to the side here. You can't tell I'm doing that, but I would not be able to do this in my head, so it's all good. And then because it's a decimal, I'm not going to reduce it to a nice fraction like we did up in number 1. I think I'm just going to literally divide. So negative 36 divided by 2.25. And actually, I get a really nice number. I get negative 16. So my function then is negative 16 x minus 1.5 squared plus 196. If you weren't totally sure how to do the second one when you were practicing this, that's totally fine. But hopefully now you're seeing that it looks a lot like that first one, like that prior knowledge we did back in chapter 8. All right, take a minute to read through this situation, pause the video, and then we'll talk about it. All right, so there's a lot of information going on here, but basically we're trying to figure out where's the best place to see the fireworks and things like that. So Antonio's on the soccer team, and his older sister Hannah has studied some physics and mathematics that would be helpful to the team. So she's using this function right here. where t is in seconds and h of t is in feet. So you can probably see where the numbers 160 and 92 came from because, right, top of the tower, 160 feet off the ground. Okay, that's kind of like my y-intercept. And then the 92 must have come from the velocity, right? It was talking about how fast it's being launched, basically. The 16, this is new. The 16 in the last term comes from the force of gravity. So typically, if you see an actual real-world application quadratic, it usually has negative 16 x squared or negative 16 t squared because of the force of gravity pulling that object back to Earth. So first thing I would recommend is kind of rearranging it, but let's read through what our task is first before we get too far. So your task is to help the soccer team find answers to its questions. Sketch the situation, write a clear statement of the questions the soccer team wants to answer, describe how you might use Hannah's formula to help them, and use whatever method you can to get those answers. So we already read victory celebration. Yay, we're good there. Now we need to draw a picture of what the rocket would look like. So we have this, they said it was being launched off a tower. The tower was 160 feet off the ground. So the rocket's going up into the air and hitting the ground down like this. A lot like our warm-up question, honestly. So I'm kind of thinking of this height right here as our y-intercept of 0, 160. We don't know the maximum height. We don't know where it hits the ground or anything like that. We know the velocity is that 92 feet per second, but that's not something that's very helpful to us at this point in time. Number 3, what are the 3 different questions the soccer team wants answered? Think of what they want to know about the path of the rocket. So if we go back, there were 3 questions that they wanted answered, so let's highlight them, okay? They want the fireworks and the timing to explode right up at the top, okay? So they need to know how high the rocket will go, so what's the height? How long will the rocket be in the air total, okay? And they need to know what is the actual, like, when it will reach its highest ground. So I think that was, how long the rocket will take to reach the top. Okay, so basically, if you're thinking of it this way, we need to know this point right here. How long does it take for the rocket to get to that highest point? And what is the highest point? How many feet in the air? And then we also need to know how long is it going to be in the air for until it hits the ground, so they can kind of figure out where are the remnants, basically, of that firework. Okay. So what I want you to do now is we're going to write down Hannah's equation. I'm going to give myself a little more room since I'm using a tablet here. Let's write down her equation, but let's write it in kind of the order we would see it. I still want you using h of t, but when she wrote her equation, it was kind of out of order. So let's put the 16t squared in the front. Notice how there's a negative with it. So negative 16t squared plus 92t plus 160. And then here is your job, okay? I've provided a table right below this. What I want you to do is actually plug in those x values, or those t values in this case, using a calculator, find the y values that go with them. So for example, let's say we're looking at 1.5, okay? Basically what I'm asking you to find is h of 1.5. If you remember back to first semester, how we talked about function notation, it's kind of what you're doing right here, okay? Please be careful when you are typing this in. This part right here is going to trip you up, okay? 92 times 1.5, again, I'm doing it off to the side on my calculator over here. That's not a big deal. The 160 is not a big deal. Please be careful with this first section, though. You do not want to do negative 16 times 1.5 first, because exponents come first in PEMDAS. So you need to figure out 1.5 squared in your calculator, which I get 2.25, and then multiply that by negative 16. And then I can add those numbers together and I get 262. So after 1.5 seconds, the fireworks are 262 feet in the air. If you have a graphing calculator, there is another option as well. If you downloaded that graphing calculator I was showing you guys before, there we go, you can actually type in literally the entire thing. So you can type in negative 16 and 1.5 squared in parentheses, plus 92 times 1.5 plus 160, and that should give you the 262 as well. So if you want to use your graphing calculator, you can. Just make sure you understand what's going on in that first section, okay? Pause the video at this point in time to fill in the rest of that table. All right, you should have your table filled out. What I would like you to do is on a piece of graph paper, or making a sketch or something like that, just try to graph-ish a picture of what this looks like. I have a suggestion for a scale. If you look, I did my y-axis up to 300, and I went up by tens each time. And I did my x-axis going up by ones, but I kind of spread it out. I only went up to 7. So we need to make sure that we have that labeled too. So this one right here is time in seconds. And this guy right here is height in feet. Okay, take a minute and graph that. All right, you should have it graphed already. Your table and your picture should look something like this. So what we need to do is now we need to actually answer the questions they're trying to figure out. So how long will it take the rocket to reach the top, and how high will the rocket go? Well, if we look back at our picture right here, okay, how long is it going to take to reach the top? Well, obviously this is the top, okay, like this guy right here, but there's not a ton of accuracy right there, because if you look at the table, you'll notice how it goes from 290 to 292 down to 286, and the problem with that is it's not even on both sides. So I'm thinking that the vertex lies somewhere in there. So that gives me a hint, with this being such a big drop between 3 and 3.5, that this must be ish when it gets to its height. And so the height must be at least 292 feet. So how long will it take? Between 3 and 3.5 seconds. And how high will the rocket go? At least 292 feet. So how long will the rocket be in the air from the moment it leaves the tower until it comes back to the ground? Well, it left the tower right here, and it's coming back to the ground. So left the tower right here. Here's our tower. And it's coming back right about here. It looks like 7 point something seconds. Notice how in the table, the y values go from a positive number to a negative number, right? Just like it does in the graph right here. That lets me know that sometime between 7 and 7.5 seconds is when that firework is going to return to the ground, or the remnants, I guess. 7 and 7.5 seconds. Okay, if you would like to, this next section is purely optional. If you downloaded the graphing calculator that I posted to Google Classroom, you can actually use Trace to get actual approximations of the exact answers. So for example, if I open it up, just takes a second for it to load. Okay, I'm gonna make it big. I can go to y equals and actually type in that equation. And then go to graph. And it doesn't show a ton of my answers, so I might want to zoom out a little bit. What you can do is you can hit the window button, and I'm actually just going to make my y maximum a lot larger, because we already know it gets up to at least 292 feet, right? So I'm actually going to go up to, like, I don't know, 320, and make my y-axis scale go up by tens. And when I go to hit graph, now it's showing a lot more of my picture. And you can actually use your cursor, so just left and right arrow, to kind of figure out those exact values. This is purely optional. This is not something you have to be able to do. But if you are planning on going into higher level math and things like that, this is definitely something that could be really helpful. Doesn't seem to want to, I have to keep clicking it over and over and over again, so sorry this is taking forever. But it looks like, okay, so here's that highest point as best I can get it. Seems to stay. So if I hit the trace button in the top right corner and kind of hit the right arrow, and it'll actually literally trace my graph. So you can see the highest point looks like Actually, might be exactly 292, just above it, right at about 2.8 seconds or so. So just